STORRM stands for Sensor Test for Orion RailNav Risk Mitigation, and it is a shuttle detailed test objective, or a DTO, that will be testing the new relative navigation system that's being developed for the Orion crew exploration vehicle. It's comprised of a vision navigation sensor, a VNS, a docking camera, reflective elements, avionics, and software. The VNS, a vision navigation sensor, is a next generation LiDAR to replace the existing LiDAR that they use in the shuttle. And the docking camera is an upgraded camera with higher resolution from what they currently use. So the docking camera is a higher resolution camera than what's currently being used on shuttle, and the VNS is really the next generation of LiDAR, which is light detection and ranging instrument. It allows you to measure range at long distances, which is about 5 kilometers or greater than 3 miles. It's a 256 by 256 pixel focal plane array, which is about 4 times the resolution of what they're currently using. And using the special reflective elements we've built for this project, the VNS will provide the data so that you can actually calculate up to 6 degrees of freedom, which currently the trajectory control sensor on shuttle can only calculate up to 3 degrees of freedom. The STORRM project is the brainchild of the Guidance, Navigation, and Control Group at the Orion Project Office at Johnson Space Center. They put out a request for proposal to all the NASA centers requesting help managing the project and also to develop the avionics and software to control the project. And Langley, with its reputation for laser instruments and remote sensing instruments, as well as being able to build spaceflight hardware, was awarded the project. In addition to managing the overall project, Langley built the avionics as well as developed and coded the software, which allows you to command, control, and monitor all the subsystems of the STORRM project. We've done a lot of environmental testing here at Langley, which we also did a lot of environmental testing out at Ball Aerospace, who is developing the VNS and docking camera. The environmental testing allows you to ensure the ruggedness of the hardware for the space environment, as well as making sure it will survive the launch loads of the space shuttle. Once the shuttle reaches low Earth orbit, the system will be activated, and as the shuttle approaches the ISS, we will collect data from the sensors and store it in the avionics from about 3 miles out. Once the shuttle undocks, we will store the same data as the shuttle undocks and flies around. And then the project has actually requested that the shuttle flies a new trajectory on this mission. The shuttle will actually fly the same trajectory that's been developed for the Orion crew exploration vehicle, and that will be our primary data collection period. So post-flight, after the shuttle lands, we will pull the data off of the data recorder, which can store up to 0.5 terabyte worth of data for each sensor. That data is provided to the Guidance, Navigation, and Control Group at Johnson, and they will post-process the data to help develop these sensors to the next stage of their development.